Hey all, welcome back to Radical Slice. I almost forgot the name of my own channel. My name is Eric. It's good to have you back. This is the next installment on my journey to recreate some of the aspects of the old NES game Kung Fu. Quick heads up before this one gets started, there is a lot of diagrams in this particular episode. So if you're into that sort of thing, I hope you get a kick out of this. If not, you can just fast forward those bits. So without further ado, let's throw it back to previous Eric. So if you've ever played Kung Fu, you'll know that the way the sort of bad guys work is they'll approach the player and then they don't actually like kick or punch the player. They just sort of like bump into them and then stop moving and do this sort of like hug of death thing. So as baddies accumulate, they'll do like a group hug thing, and that's how the player will lose health. So in our case, thinking about collision, we need to check for a couple things here. Let me just I'll make some notes on this. You can see I really stepping on my paint game again here. I'm like annotating a screenshot. So we know we have the player's bounding box here in green. Let me make some notes here like this. So we need to check when the enemy's bounding box overlaps with the player. And what that'll do is like trigger the stop, the enemy to stop moving, right? And do the hug of death thing. So that's easy enough. The interesting part comes into play because we have multiple baddies over here, right? So if we just like let the baddies only check for a collision against the player to tell them when to stop moving to the right, they'll all be like right here, right? They'll just be like stacked up against each other, and we won't get the cool group hug of death thing that I want to get. So we need to check for two things in baddie collision. We need to check first, one collides with player. And in this case, I think also that we'll have a state change for the baddie. So right now the baddie only has one state, and that is walking, right? So we'll change the baddie state from walk to, we'll call it hug. And the second thing is like collides with other hugging baddie. All right, so we wouldn't expect that there would be a collision with baddies in the walking state, but just to be thorough. So there will be two cases that will stop the baddies. One is it'll collide with the player, it'll do the hug of death. The other thing is if it collides with another baddie who's already hugging, it'll also stop. And that should give us the group hug aesthetic that I want to get. Okay, a little bit of progress, and let me just explain where I'm at and why things look the way they do. So in main, in the update bit, I'm getting the player's bounding box and I'm passing those coordinates, again, that's the upper left and the lower right, into this player collision function in Baddie Manager. So because the logic is going to be different depending on whether the baddie collides with the player itself or the baddie collides with like the player's hands and feet, the punches and kicks, I decided to just separate those two functions. So I'm calling player collision, and what that looks like is I'm actually keeping a count of how many baddies are colliding with the player, and I'll talk about that, why I'm doing that in a minute. But all I'm going to do is loop through all the baddies. If the baddie state is already hug, that means it's already colliding, so I'm just going to increment the number of colliding baddies with count. Otherwise, I'm going to get the baddie's bounding box, and I'm going to call this like library function for a collision. Again, it's just bounding box collision. If the collision is happening, I'll change the baddie state to hug. And that's it. That's all I'm doing. And then I'm returning the count here. So if the baddie state is hug in the baddie's update function, that means I stop updating the value. So you can see right at the top, if the state of the baddie is hug, it just returns. That means we skip all the animation bits. We skip the updating of the X position. We skip everything. So the baddie just kind of stops and sits there. The reason that I am returning the count of baddies is because, again, in the original Kung Fu, and I'm not sure that this is exactly how it works, but as the baddies kind of pile up on the player and will sort of hug of death the player, and you have to like get out of that state. You can't like punch and kick normally. You have to, I think what has to happen is you button mash to like get out of it. And so I think that button mash kind of scales up depending on the number of baddies that are hugging you. Um, so I want to keep track of how many baddies are currently hugging so that the player has to like, button mash a little bit more, a lot more, depending on that number. So that's why I'm returning that value here. So what this looks like is what I was describing before. Because we're only checking for the player collision, the trees will pile up when they hit them. So it's going to go bump, 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 bump. So that collision is working great, but we're not checking for collision with other trees, with other baddies. So they kind of stack up on themselves. And that's not great, right? We want them to sort of hug of death and sort of do the group hug look. So that's what I'm going to work on next. All right, pretty good progress here too. So all I did was I added another loop inside the baddies. So now the baddie doesn't just check for collision against the player, it's also going to check for collision against other baddies. And the baddie that it's checking has to be hugging already, right? So we're going to just disregard any baddies that are not hugging when we do this. The other thing I did is because we're looping over the same table of baddies, you're gonna like compare the baddie against itself. So you have to make sure that you don't do that. So if you compare it to see if a baddie is colliding with itself, the answer will always be yes, because the dimensions are exactly the same. And so those two boxes are always going to overlap. So I'm kind of cheating here because we know that two baddies would never have the same X position and be in a hugging state. I'm just deduplicating the baddie check by saying like, hey, if the baddie in the main part of the loop has this X position, and the baddie in the inner loop also has the same X position, we can assume that they're the same baddie. So just like don't do the check in that case. And that worked out pretty well. That's a bit of a cheat, and it may come back to bite me later, but for now it's working. So the trees work, boom, 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 just like we would expect. They sort of stack up, and now they're hug of deathing. And I also sort of debug printed the number of current huggers in my main, and I can confirm that like it's the number that I want right here. We currently have 3 hugging trees, so that'll allow us to do the sort of like button mash mechanic when we get to that part as well. So now the thing to work on, I think, is to actually see if we can like fight these guys. Let's see if we can fight some trees. I'm going to do the collision for the hands and feet part now. Now, just one note as I was working on this, one thing that's like kind of interesting is, well, one thing is like it works. So that's cool. Bang, bang, bang. So one thing that's kind of interesting though is if we're in the hug of death state, and I take care of that first guy, the other trees like don't return to their walking state, so they're still like in the hug state, and that's because I'm not actually like resetting them if they're not colliding with the previous fella anymore. So after, I think what I have to do is sort of, hang on, let me think about this. I think I'm going to have to tweak the collision algorithm that sets them to hug to sort of unset them to hug if there's no tree immediately like in front of them. So let me go ahead and make that change. Okay, so I want to talk a little bit about collision because things got really interesting really quickly. And I want to talk about how I kind of solve this problem. So we know the player's bounding box is like, oops, here, and then each of the trees had their own bounding box. All right, and this actually worked pretty well. The problem was because the check to stop the tree from moving was checking for 2 different things. It was checking to see if it's impacting the player, and it was checking to see if it was impacting another tree. So we ended up with this group hug situation. The problem shows up when, let's say the player was to get rid of this tree. This tree's gone now, right? And now what we want to happen is we want these back 2 trees to keep going forward, to like stop from the hug state and go back to the walking state. The issue is that these 2 trees are already colliding with each other here, so they are locked in this like perma hug of death that they wouldn't go forward. So this is pretty tricky to solve. What I did was I introduced two different collision boxes. You can see, I'll show you in the Pico-8 thing in a minute what that looks like. But so the player collision logic didn't change, but the sort of the two tree collision logic did change. And what I did was when I checked to see if one tree is colliding with another tree, I'm not using the full indigo bounding box. I'm just passing one red bounding box and one purple bounding box. So really, we're only checking. Let's say for these front two trees, this second tree is gonna use this red box to check for collision against the front tree's indigo box. Right? And that's the only time when the tree will stop and move from a walking state to a hugging state. In this way, if the player gets rid of this tree and kills this tree, even though the back two trees are still locked in a hug of death, this middle tree now is going to check again to see if its front-facing bounding box, this red guy, is colliding with another tree. And this part is not, right? The back part, the full lavender box here, or indigo or whatever, is still colliding with the back tree, but we're not checking that anymore. We're just checking this front part. And since there's nothing here, that allows the tree to advance forward. Sorry, I know that's like super convoluted, but basically what I found is having different bounding boxes for different collision scenarios can be quite helpful. And if we have a look at Pico-8, you can see how this is represented on screen. And if we let this play out, so let me spawn in a few guys from the left first. So what we should see is they'll stack up against the player, and then I'll punch one of them, and the first one will disappear, and the remaining two will advance forward. Guess that looks good. Punch. There we go. Punch. Punch. Right. So that's the behavior that we want to see. As the player kind of knocks down trees, the ones in the back of the group hug will move forward. It works the same way if we go from the right, and in fact, we can spawn in guys from both sides by doing this, and they'll both stack up on both sides. So we can just kind of like alternately like kick, punch, kick, kick. Oh, cool. And the kick has like quite a bit of range, and so it can actually take out two guys at once right now. That's something I'll have to tweak. So yeah, I'm pretty stoked about that. So that takes care of like combat and the group hug mechanic. So pretty good progress. Boom, 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 boom. Before I go any further with the mechanics, I'm going to do some aesthetic tweaks and maybe add another enemy type. Not at all what I expected I would do. So let's talk about that. Let's talk about how that came to be. So the first thing I want to mention is that I drew a new floor. So rather than using a green rectangle, I'm going to use this sort of desert sandy aesthetic. I copied this pretty shamelessly from the Super Mario Brothers 3 desert floor vibe because it was really cool. One thing that surprised me about this is I expected to use orange and yellow a lot to do sand, but they sort of blend orange with this peach color, which I thought was pretty neat. So yeah, I mean, obviously there's a lot of like kind of funky pseudo arbitrariness about these grains of sand, so I didn't copy it pixel for pixel. But in terms of using this color scheme, yes, I just stole this from Mario 3. I think it looks fantastic, so kudos to the pixel artist from back in 1988. Okay, so once I draw this on the screen, it looks like this, and that looks pretty good. So our guy's going to walk around. You'll notice I have some debugging message at the top there. And oh, what happens when he gets to the middle? He just stops for a second, and then he goes to the end. Let's try that again. Let's go the other direction. And oh no, he like gets stuck, and then he goes to the end. So that's actually what I want to talk about here. So if we use Kung Fu as a reference, what happens is your player is always sort of drawn in the middle of the screen as you progress through the level. The only exceptions are right at the beginning of the level, you can walk back to the right side, right to the right edge, and as you progress far enough into the level, as you reach the end of the level, you're allowed to walk to the left side of the screen. But otherwise, you're always going to be drawn kind of right in the middle. And I wanted to replicate that. So essentially what that means is we're going to have two sets of coordinates, right? We're going to have the player's x, I guess just an x coordinate really, because y isn't changing, but we're going to have an x value for how far the player has gotten through the level, because it's going to be longer than just one screen on Pico-8. And we also need an x coordinate for where we're going to draw the player. And that needs to change depending on where we are in the level. So let's draw some diagrams. Okay, so let's draw a level. So let's say all of our levels are going to be 1,000 pixels long. And I think it's fine for this particular slice to just have fixed level length. I'm not going to get too worked up about that. And in our case, we're starting the player, we're moving the player from right to left. So let's assume the player is going to be starting kind of like right here. And as they progress through the level, we're going to keep track of that with a value called mapx. Actually, let's do this in a different color. So our initial map x is going to be here. We're starting towards the right-hand side of 1,000, so our map x is going to be, let's call it like 984, something like that. And as the player progresses through the level, this value is going to decrease. So as we go this way, we'll do map x minus. And until this point, we're okay drawing the player like as they're moving back and forth, but the value is not going to be obviously 984 because Pico-8 only has 128 pixels to work with. So if we tried to draw it at 984, it'd be way out the screen. So the actual value here is going to be, for where we draw the player, is going to be 128, which is the max extent of Pico-8's screen, minus 1000, which is the map extent, minus, again, the current player's map, or the player's current map x. Right, so this, on this right-hand side of the screen, this value here is going to be pretty small, right? It's going to be between, well, we're going to force it to be between 64 and 128, right? So what this allows us to do is that as the player reaches a certain point, traveling from, in this case, left to right, towards the right-hand edge of the level, that they'll be able to reach the edge of the screen. So that's how we do kind of the right third of this situation. So let me we'll make like a delineation here. Hold up. This is the math we'll use to determine the player's draw position if map x is greater than the map extent minus 64. We can kind of do something similar over here. So in this case, it's a little bit easier because the values map more directly to like actual Pico-8 coordinates. So if map x is less than 64, we just set draw x equal to map x and we draw the player exactly where we would expect them to be. And then finally, in the middle, we have our else case. And so Even though like that's not the order the conditional goes in if we're reading from left to right, but we check, if it's greater than this, we check if it's less than this, and then if nothing else works, then we just draw the player at 64, right in the middle of the screen. Equals 64. And that is how we are able to get the effect that we see here. So in my diagram, I was using the example of 1,000 just to make it look prettier. But actually, I'm using a value of 200 for the map length here, for the full map. So the map is only a little bit bigger than one Pico-8 screen. And we're starting the player kind of at 184. So we're starting at the right-hand edge of the map, and we're going to go from right to left. So in this situation, the player can move back and forth just fine. And if we try to move to the right-hand side, I have some limits on there that's kind of stopping the player from moving any further. And as we move to the left, you'll notice that after we reach a certain point, it'll stop. So map X is still decreasing, but the player doesn't progress beyond the midpoint of the screen, which is kind of what we want. But after a certain point, once we get below map X of 64, then we allow the player to proceed to the left-hand side of the screen, which would be the goal. And this will work if we go in the other direction too. Just like that. So there's sort of like this little sort of space distortion field in the middle of the screen that is related to how long we set the map to be. And just like in Kung Fu, assuming we're going to do more than one level, we want the player to go either left to right or right to left. Like we want to allow for both of those possibilities. So this works in both directions. We just have to, in the case where we're going to have the level go from left to right, we'll just start the player on this side and have them progress like that. Now the only element of this that is not done yet, which observant viewers may have noticed, is that the background's not scrolling right now, or the floor is not scrolling right now. So that'll probably make this make a little bit more visual sense. That's what I'm going to tackle next, I think. All right, so let's talk about infinite scrolling. So the way you normally want to do this is if you have a really long level, right, you don't want to draw that whole thing in the map editor. Let's pull up the map editor to show you what I mean. So here we've only defined x equals 0, x equals 19. So I've gone a little bit beyond the borders of the screen, but I've only defined, about 150 pixels worth of tiles for the map, right? But we want our levels to be arbitrarily long, right? And we don't want to just draw the same tiles, to infinity. And that also limits the length of our levels by the length of Pico-8's little map function. We want to have this just kind of repeatedly scroll, right? So the way that this is normally accomplished is you just kind of draw this once, like I've drawn here. So let me draw some sand here. And let's assume this is 128 pixels. So this is just our one screen map, but if we want to scroll this, the easiest way to do it is to just copy it and put it next to itself. Like this, and pretend there's no gap in here. We'll sort of fill that in. Okay, so you've got two 128 pixel maps right next to each other, and as the player moves forward, because the screen is only 128 pixels wide, you're only looking at 128 pixels. You're only looking at part of this map, and the camera and the part that the camera is showing just sort of goes from here to here to here and back again. You're just sort of looping through it, right? You can do a modulus operator to ensure that the value of the x value of the camera is always between 0 and 128, right? Now, if we just try to do it this way as is in our little game, because of the funky way that we're doing scrolling, let me show you what happens. It sucks. And I want to show you how it sucks. So our player starts over here, and as we walk to the right, see, we don't want the sand to scroll right away, right? We want to wait until the player kind of gets to the middle of the screen there. But if we just do this as is, the background is scrolling, and then here it gets normal, right? Here it makes sense. But then as we reach the left-hand side of the screen, we don't want the sand to continue scrolling after that point. We want it to stop here and be fixed. So really, we only want this scrolling effect when the player is kind of right in the middle of the screen, and otherwise to be static. So the way I thought to do this is pretty straightforward. What I said is if the player's map X is greater than 64 or less than the border of the sort of extent of the map minus 64, then we do the cool like double screen thing. Here, all this is doing is just like what I just explained in that diagram. We're just drawing the map twice next to each other. We're using modulus to make sure the value is never greater than a certain value, and that allows the background to scroll. Otherwise, we just draw a static map, and that's all, right? So that'll force the screen to stop when the player reaches either the left or right edge of the map. Now, what's interesting about this, or what was kind of annoying about this, is if you watch carefully, and let me make Pico-8 larger so you can kind of see what's going on here. As the player walks to the left, everything's cool, right? We got that fixed background here. But then as we walk to the left, oh, it kind of jumps when we reach 64. Ah, and that's unfortunate, right? We don't want that to happen. It looks okay here, and when we go back this way, it looks okay. But then when we reach 64 again, it jumps. So let me like make some annotations on the map to kind of show you what's going on here. I've labeled the 4 tiles that we're using as 1, 2, 3, 4, and you can see that everything works well here. And then when we go in the middle of the screen and we try to move from tile 1 to tile 4, you'll see the numbers jump. Oh, right. So something's kind of funky with this value. Now, astute viewers may realize what's going on based on some of the previous discussion about our map extent, like the length of the map that we're using. I had originally set the value of our map's extent to be 200, right? 200 pixels or whatever. So let's jump back to the terminal real quick. Up here, I set it to be 200. And what I realized is this makes the math funky. So this scrolling part is sort of kind of dependent on the value of the map extent being a power of 2, right? So 200 is definitely not a power of 2. So the way I worked around this is I just set this to be 256. Now if we restart, as we walk to the left, you'll see that everything lines up normally now. And that happens in both directions as well. So there may be a more elegant way of doing this, but what I found is no matter what sort of tweaking I tried to do to this bit, I tried like doing different offsets and different values for the modulus here. No matter what I tried to do, it was always broken in one direction or another. And so I was like, well, I'm not really married to having the map be 200 pixels in length or any particular value in length. So as long as I keep it to a power of 2, that should be fine. So that's kind of how I solved this funky scrolling problem. But hey, as you can see, now it's working beautifully. This is exactly what we were looking for in terms of scrolling. And as I said, part of our goal was to not have to draw the entire map out, depending on, like we want to have levels be arbitrary length. And so this accomplishes that. We get our scrolling background, plus we get the sort of like time warp effect or space warp effect in the middle of the map. Hey, thanks everybody for watching. Like I said, there were a lot of diagrams. I hope you got a kick out of that. If you did, feel free to stick around, and there'll be a new video coming up real soon in the same series. Until then, I hope whatever development efforts you're working on are fruitful. If you're just like kicking it playing games, I hope you're having a good time doing that too. And I'll catch you next week. Bye for now.